Okay. In our notes, yes, I know it says chapter 10 up at the top. Remember I told you that chapter 11 and chapter 10 will represent pieces of chapter 10 into this chapter. So technically we're still in chapter 11, even though the focus is from chapter 10. I'm just putting it all in one big thing. Does this make sense?
Yes.
Okay. Because we need to understand how to do 10.1 and 10.2 before we can go to 11.3.
So we'll go back.
So yeah, we're going to go forward. Yeah. Yep.
It's like
Anyway, okay, so circles. Really appropriate because tomorrow's Pi Day. Usually this is how I try to set it up so we can get circles a little bit for Pi Day.
So we're not going to take any notes tomorrow, are we?
Tomorrow we're not taking notes.
No, that's correct.
What?
Which is correct.
Tomorrow, probably wouldn't do that.
Yes.
Yeah. But tomorrow will be eating, and I'll read you a story, and we'll do an activity.
So, none of your classes will have to learn?
None of my classes will. Unless they deserve it and they can't be
On that,
So
we're getting home.
Not
you,
That would be okay. I mean, you want to bring a little bit of something, that's fine. Like, obviously don't bring something so maybe you can't finish. I know, but I mean, I guess it's really what I don't know. I don't, so, you know, I don't think you can put it in here, but I don't want to like proceed. Alright, anyway, let's keep going. So circles. Circles. Okay? It's a set of all points in the plane equidistant. That's all one word. Wow. Equidistant. E-Q-U-I and then distant. Equidistant. What does it sound like? Equidistant. That's exactly what it means. Yeah, why can't they just say equidistant? Because equidistant just sounds cool. One word. Don't tell me that. Anyway, so circle. Set of all points equal to a given point. This given point is called the center of the circle. The circles are named by their center. In other words, if I was looking at this circle, what would I name it? Circle C. Circle C, because the center is C. Pretty easy. Okay? So segments that intersect a circle have special names. First, we have the radius. If I have more than one radius, we call it radii with a double I on the end there, which sounds kind of weird. It's kind of like octopus and octopi. It just kind of
Aren't like all radius and round always equal?
in the same circle, yes, but if you're talking about multiple circles, not necessarily. But good point.
Can I bring an octopus tomorrow and we can eat octopi?
It's round. Okay, so radius or radii is a segment with endpoints at the center and on the circle. When they say on the circle, they mean the edge of the circle. So if I was looking over here, one radii would be CF because it starts at the center and it goes to the edge. What's another one?
DC.
DC, and another one would be C. Good. Remember, segments, we put the line on top with no arrows because it's not a line that goes on forever, it's a line segment.
You have to always name it like starting with.
Oh, that's what you're missing. Not necessarily. I usually do just because I always think from the center to the outside, but it doesn't matter what we're doing. Alright, a chord. A chord is a segment with endpoints on the circle. So if I was looking at our picture, I could say AB is a chord because both endpoints are on the edge of the circle. What's another chord?
D.
D. And a diameter is a special kind of chord. It's a chord that passes through the center. So we've already named this diameter. In this picture it is
D.
D. Okay. So example 1 says, name a circle and identify a radius. So what would I name the circle?
Circle B.
Circle B.
Is there like a shorthand symbol for circle or you just like that?
Sometimes the book does a circle with a dot, and then you'll say the circle P. I don't know. Sometimes the book does that. Okay, for the radius, which purple to choose from?
Good job.
Sure.
You've got a golf club, boy.
If you look at it, look at his eyelids.
You look, yeah, okay. Sure.
Oh, that.
There, see, it's a little monster with a strong
That's too, like, distracting for your
But anyway,
Isaac Wood.
I'm glad you have such vivid analogy. Okay, anyway, tell me, name a radius in this circle.
Yeah.
Yeah, okay, one. Give me another one. I know it only asks for one, but let's ask for another one.
Yeah.
And?
Yeah.
Okay, on B, it asks us to identify a chord and a diameter. So, let's name a chord first. JK. Can I name another chord? Can I name another chord? No, that's it. How about for a diameter?
The diameter would be 16.
Name another one? No. Nope. That's it. Okay, part C says, name the circle, a radius, a chord, and a diameter. So we want all different kinds of things. So first, I would name it a
Circle X.
Okay, they're just asking for one of each. So, okay, so let's name a radius. Doesn't matter what you like. X. Okay, name a chord. The diameter. Very good. Any questions on the front side? Pretty much today, since I get used to all the different books now. Let's go with two today. It's in the book. Okay, so the distance from the center of the circle to any point on the circle is always the same. As like Zoe already pointed out, in a circle, all the radii are always going to be the same length. If they're not, then it's not a circle. Therefore, all radii, which should be of a circle, not the word circle, of a circle, are congruent. And all the diameters of the circle are also. In other words, if I was going to say, let's see, okay, so if I have this circle and I've traced this radius, right? So if I was going to take it and I was going to turn it, notice that the radius is the same distance all the way around. It looks kind of long. It does kind of look like a lot, doesn't it? Okay, so the radius doesn't change. It doesn't change its distance. If it did, it wouldn't be a circle. It would be like an ellipse or an oblong. Okay, so all the radius is going to stay the same. Same with the diameter. It's going to be the same distance no matter where I put it. All right, so diameter and radius relationships. So I know you probably learned since like 3rd grade that a radius is going to be half of the diameter, right? So if I take diameter divided by 2, I get to radius. So if I take radius and I take it times 2, I get to the diameter. That's what these two are saying. And in example 2, it's asking. It says if QB is 8 inches, what is the diameter of this circle?
16 inches.
16 inches, I know.
Because the diameter is 2 times the radius.
And I give us the radius is 2 times the radius. Alright, TV is 14. What's the radius?
7 inches.
And the Okay, QT is 11 meters. What is QU? Good.
Wait, so when we place for, will we have to find the area of it?
Today we're not talking about everything. We will eventually.
Wait, so you go up
Alright, circle pairs. We have congruent circles. Congruent circles are two circles that are congruent if and only if they have congruent radii. So in other words, if GH is congruent to JK, then I can say that these two circles are congruent. Circle G is congruent to circle J. So remember, if things are congruent, if shapes are congruent, that means they have the same size and same shape. Well, all circles are the same shape no matter what size they are. So as long as they're the same size, we say that they are congruent. And concentric circles are coplanar. What does coplanar mean?
It means they're on the same plane.
On the same plane. Okay, so coplanar circles that have the same center. They don't have to have the same radii. They could. They could be right on top of each other. But as long as they share the same center, then we would say that they're concentric. It's like they make a bullseye. Like a big bunch of concentric circles. As long as they start at the center and go out, we can make it go like that. Oops, that's not quite at the center. But we can make a bullseye, and they would be all the same center. Okay? Circumference. Circumference is like the perimeter of a circle. Circles kind of tend to be the snobs of the geometry world figures. They always have to have things that are a little bit different, it seems like. So we don't say the perimeter of a circle, we say the circumference of a circle. So this is our circle. We have two different formulas. We can say circumference is equal to 2 times pi times radius. Or, since 2 times radius is equal to the diameter, we can just say diameter times pi. Alright, example 3, it says find the circumference of each circle described. Find both in terms of pi and rounded to the nearest 100. Let me explain this for just a second. So in terms of pi, means that they want to see the pi symbol in your answer, and you are not going to take it times 3.14. If they say rounded to the nearest 100, that means, do actually take it times 3.14, and there is no pi symbol in your answer. Make sense?
So we don't push the pi button, we round it before we multiply to 3.14.
Oh, you can use your pi button, or you can multiply by 2. I would take. I think the book usually uses the pi button. When I work problems, I usually use 3.14. Yes.
Which one will I do with that?
Oh, I would take either one. Alright, so let's first do it in terms of pi. So they give us the radius. If I'm looking for circumference, which formula should we probably use?
The first one.
The first one, because they give us the radius. Circumference is equal to 2 times pi times radius, which is 2.5. So then we can simplify what's 2 times 2.5.
35.
So in terms of pi, I would leave it like this.
Better than pi or pi.
Usually with pi at the end. We treat it like an x. Okay, so that is our first answer. That's in terms of pi. If we were going to round it to the nearest 100, then I'm going to take it to 5 times 3.14. 100 means how many decimal places? 2. 2 decimal places. What would we round it to?
It's about 15.71.
Notice I put squiggly
So we
equal.
do have to use the actual pi button as well, because normally it's just 15.7.
Yes. I would have taken either answer. The pi button is more accurate than 3.14. You could use 3.49, and that would get you closer, but pi button will get you closer.
I'll just use the pi button.
That's plus.
If you want to do that, that's fine. All right, diameter. Which formula should we use in this case?
Second one.
The second one, diameter times pi, so we're just going to take 16 times pi. Oh, look at that, it's in terms of pi, that's all we have to do for that one. And then if we were going to round it, take it times 3.1415. 27?
Yeah.
Okay. Again, notice I put squiggle equals in front because we rounded. So in terms of pi, go take it times 3.14 and leave your pi symbol rounded. Actually, just take it times pi. And there's no pi symbol left because you've already taken it times pi. Does this make sense? Some people get those two confused, so they're confused. Okay? Alright. Example 4 says, find the diameter and radius of each circle to the nearest hundredth. So they give us the circumference. So I would take circumference equals diameter times pi. That's the one I would start with because we're finding both diameter and radius. So circumference is 106.4. How am I going to figure out what the diameter is?
I rated 33.87.
33.87. Oh, and round position looks good. Oh, I don't get you.
So then 0.87 divided by 2.
Yep, 200 is really divided by 2.
Okay.
So 16.9.
Ah, something's coming.
So when we divide it by 2 to get the radius, we don't have to use the big number, we can use the rounded number.
Really, we should use the big number, but I will take that. All right, you want to do the last problem, or you guys got it?
I got it.
Got it?
Oh, geez, we have a long time. I'm just getting started.
Just getting a chapel.
It's